In this example, we're going to find the volume that's generated by the region that's bounded between the given curves. And that region that's bounded by the curves, we're going to rotate it around the y-axis. So we have this green line right here. That's the line y equals 3x. Then we have x equals 0. That's our vertical axes, the y-axis. And then the line y equals 9 is this purple line right here. So the area that's bounded is this area here that I'm shading in yellow. So we need to take this area and spin it around the y-axis to create a volume. When we do that, we're going to spin it this way. We're going to get what looks like a cone. Now, to find this volume, because we're spinning it around the y-axis, when I take my slices and I cut it like this, I'm going to have a solid disc. But because I'm slicing it this way, we're going to have to do this with respect to y. So when I try to find the area of this disc to help me find the volume, when I look at this disc and I come out this way to determine what that radius is, that radius is going to be whatever the value is for that line. But we're doing it with respect to y, so we have to solve y equals 3x for x, so it's in terms of y. So we're going to get x is equal to 1/3 y. So when I come out this way to find my radius, if I think of, let me try a different color here. If I think of this as taking a cross section, that will come across here. My radius is going to be 1/3 y. So to find the area of the disc, we're going to do pi times radius squared. And then the radius is 1/3 y, and this whole thing is going to be squared. And then I have dy. Now I got to figure out what my upper and lower limits are for integration. Again, because we're doing this in terms of y, we want to go from 0 to 9. That's this distance from here to here in terms of y. So I'm going to write 0 for my lower limit and 9 for my upper limit, and then this will give me the volume of that cone that we created by rotating this line y equals 3x about the y-axis.